Number 8, discussion. This is the part, so you present your results in the last and your analysis as well in the results section. And after that, you want to discuss what your findings are in this section of discussion. You can come to the conclusion in this part. There are a few things you can do in this section. For example, do you see always a positive arrow in your findings? Does that mean a systematic arrow? Any trends like that? For example, if you're looking for the reaction order, and does that order suggest any mechanism of the reaction? Okay, and the relationship to what's theoretically expected. So in your theory, you are expecting a linear relationship between natural log of pressure versus 1/T. What if you didn't find that relationship in your results section? Is there some deviation not included in your experiment, or some other factor contributed to that deviation? And the comparison to literature values. So you should be able to have the literature values from homework 2, and you can make a comparison to that. There are a couple ways to compare. So one way is to compare the absolute value. Is your boiling point is always higher than the literature value, or always lower than the literature value? So that's absolute comparison. The other is the relative comparison. Is your boiling point 5% higher, or 10% higher, or 20% higher? So that's a relative comparison. Sometimes relative comparison is more important because the absolute value can be large. However, if you are comparing larger values, the relative comparison can actually be small. Relationship to common area of understanding. So for example, if I'm trying to figure out a reaction mechanism, does that matches with what we learned from organic chemistry or inorganic chemistry? Comment on the level of uncertainty. If you are getting a very large uncertainty level, how that's get involved such a large uncertainty level. And the other thing is, if you have a certain uncertainty, if you have some systematic error, how would you suggest possible future experiment that may increase or clarify understandings? One way to do that, when you propagate arrows in experiment 2, you can look at the arrows you get from delta H and the delta S, right? If you just look at the boiling point temperature. So which one contribute the most? For example, let's say delta H contribute the most in the boiling point temperature arrow. Then is there any way to decrease the uncertainty in delta H? Can you use a better pressure meter with a higher precision, or can you use a better thermometer with a lower uncertainty? Okay, things like that. So I also list a few things that you may consider to discuss in your vapor pressure lab. One is appropriate to use the Clausius-Clapeyron equation. So I'll plot linear. Remember in the science handout, there are 2 scenarios. We use the scenario that the delta CP equal to 0. So what if the delta CP is not 0? That's going to affect the linearity of the plot. Does that matter, or that doesn't matter in your case? Okay. The other thing is compare the entropy values, normal boiling point results to literature values. You can do the absolute and the relative comparison and discuss why this may be. And then you can compare all those above values between cyclohexane and ethanol. So we have 2 molecules. So you can do the compare between these two molecules. You may notice that the molecular weight of the cyclohexane is much larger than ethanol. However, their boiling point is similar. So why is that? Does that suggest any chemical structure difference? Or is there any other mechanism that make one of the boiling point higher or lower? You can also discuss the level of uncertainty. Are there sources of a systematic error? So remember, if you want to identify a systematic error, you need to look for the uncertainty that's always in one direction. It's not up and down. It's always in one direction and with a similar amplitude. How could this experiment be improved? So do you think the uncertainty in thermometer is good enough, or smaller improvement in thermometer uncertainty can greatly improve the precision of your boiling point temperature? Okay, so what system could be studied that would improve the broader understanding? So you don't have to discuss all of these. It'll be good if you can find at least a couple points here to discuss in your lab report. Number 9, references. A citation need to be in numerical order in which they appear in the report text. The first citation is usually given a superscript 1 at the end of sentence, or sometimes a clause in a sentence. If you are going to repeatedly cite that reference again, that reference still be reference 1. If you are not familiar with a certain formatting style, you can always Google. You just use the keyword ACS citation format style for what kind of a reference style or what kind of journals you want to use. Also, our library carries a copies of ACI style guide. That's a hard copy. I list a few different styles here that you can use if you have a book you want to reference. That's how you reference a book. And if you have journal articles, that's how you want to reference a journal article. If it's an online database, you can reference this way. Number 10, the calculations. I don't need you guys to include all the calculations. Just provide one example of the calculation. If you have an error analysis, so for example, in the vapor pressure lab, you need to do the partial derivative of delta H and the delta S to calculate the uncertainty of the boiling point temperature. So I want you guys to include that part of a calculation, and that you can use Excel as much as possible. So if you use Excel, I want you to include a screenshot of the data table you got from the Excel. Make sure include unit and formula used. Okay, this part can be handwritten, and it can be part handwritten and part print. So if you include an Excel table, you can write your comment on top of that table, or pointing arrows where I should be able to find your uncertainty also a big table.